Whoa, what the hell is this? This is 10 years ago. I don't think I could do this now. Find the age at which the dating pool is largest, correct to 1 decimal place. Let's find out. As you guys may already know, I've moved in back home with my parents in Palmerston North. That's given me some time to think. So I was in Pekingese of all places, and I thought about the coolest exam question I've ever been asked. And that made me think about an exam I did back in 2010, a calculus scholarship exam. Now the reason it was such a cool question is because it involved a comic called XKCD. It's a really cool comic, you guys should check it out. There's actually one comic on there about climate change which I think is quite profound. Now this comic talks about dating for 17-year-olds and 16-year-olds, which I think is quite appropriate for given that age, and I think it's just a cool question. So I think we'll just jump in and check it out. There you go, look at that. Shakespeare, one of the best writers in the world. Here it is. 2010 scholarship paper. Perfect. So I've got it right here, guys. It's the 2010 scholarship calculus exam that I did back 11 years ago when I was 17 years old. If you guys don't know, scholarship calculus is basically, it's an extra test that you do at the end of the year on top of your NCEA exams so you can get some money. I am proud to say that I did get scholarship calculus. I'll show you the results here. You can see I got a cool 20 out of 40, so 50% for the actual course is actually quite common. So that was enough to get a scholarship in calculus, I think, back in 2010. Now we're going to pop through that question. This is probably the most interesting question I've ever had given to me in my entire academic life. It's question number 5 in the 2010 scholarship exam. So I think we should jump straight into it. And what I've got here, I've got a camera set up right here. I'm going to try my best so you guys can see what I'm actually doing here, but I do apologize if this doesn't work out. So basically it has 4 little quadrants on there, and it's basically a woman thinking that she's 26 years old, which is freaking young. She thinks she's gonna, the number of singles she can date is getting less and less and less as she gets a bit older and older and older. But the guy tells her it's fine, you can date anyone as long as you don't do the age over 2 + 7 rule, which I think is really cool. I think it's hip hop culture, and I knew about this rule in a freaking exam, a scholarship exam for nerds. So I think we'll jump into the question. The comic strip doesn't really tell you too much, apart from the age over 2 + 7, which is really important. Okay, let's jump into the question. So, a simple model fitting the general shape shown in the comic strip for the proportion of singles of age t is the equation, which is st equals Euler's number to the power of negative 0.05 t for t is greater than or equal to 18, where t is measured in years. Suppose, for the sake of the question, that the model is accurate and that all singles date accordingly to the rule given in the comic strip. A. Find a rule for the upper limit for the dateable range of a person of age t, and hence the width of the dateable range of a person of age capital T. So basically we're just going to use that age over 2 + 7 and reverse engineer that. So we know that the lower limit, the age which is going to be t over 2 + 7. So what we're going to actually do is we're going to use this age over 2 + 7 rule and reverse engineer it to find the upper limit. And the way we do that is we actually make the lower limit equal to t equals the upper limit over 2 + 7. All we need to do is to make the upper limit the subject of this equation. That's it. So what we'll do is we'll rearrange it. Upper limit over 2. So I'm going to subtract 7 from both sides. So that's t minus 7. And then what I'm going to do is upper limit, I can multiply both sides by 2. Upper limit equals 2t minus 14. And that should be the first question done. Great, so now let's move over to the second part of the question, which is integrate st between lower and upper limits to find a measure of the dating pool for a person of age t. So, I'm actually I can't remember how to integrate, so I'll be back in just a second. Great, I'm back. I just learned how to integrate. All we need to do is integrate this. I'm going to find the definite integral using the upper limit and the lower limit, which we came up with. The lower limit being t over 2 + 7, and the upper limit being what we found out in this question here, which is 2t minus 14. And that's the lower limit there, t over 2 + 7, and the upper limit is 2t minus 14. Okay, so now what we have to do is we have to work out the integral. So I checked, so I'm going to write this down here, and I do apologize if this is really small. And we've got an upper limit of 2t minus 14 and a lower limit of t over 2 So to work out the integral of Euler's number, I actually had to look this up. Let's come over to this problem here. So essentially, you take the derivative of the exponent and you divide it by that derivative. So back to how this translates to our problem is we have negative 20. Remember, because that is 0.05 equals 1 over 20. So dividing by that gives us 20. We keep all this the same. Easy, right? And we put our limits in there, which is 2t minus 14 and t over 2 plus 7. Great. And let's expand this guy out. Our lower limit, t over 2. And that's our integration there. I'm guessing we can leave it at that. We can just simplify it with the next question. So the last question that we're being asked, and what we've all been waiting for, is find the age at which the dating pool is largest, correct to 1 decimal place. Let's find out. We basically have to get this equation, differentiate it, make it equal to 0 to find the maximum, and then solve for t. That's what we have to do, which is actually what I'm quite interested in. So what we need to do is just basically simplify this to make it easier for us to work out, essentially. All I need to do is basically expand these out, which shouldn't be too bad. Gosh, I really hope I'm doing this right. There's t there somewhere. Great, so now what we need to do is differentiate this massive equation here. So differentiation is really easy with Euler's number to differentiate. So imagine we have a function, and all we need to do when we differentiate Euler's number is we just multiply it by the derivative of the exponent. So this just becomes really easy. So the derivative of this exponent will just be simply negative 1 over 10. This is going to become 2. So when we differentiate this, which is a bit of a jumbled mess, it's negative 1 over 40 t minus 7 over, so what happens to the constant? It just disappears. 1 over 40 times 20, which is 0.5. We make that equal to 0 because we're trying to find we're told that it's going to be a maximum. So what we're doing basically is we've got a graph like this. These are all our ages on the x-axis, and this is basically the area. We want to find the age. So imagine we've got this graph here. We can't tell what it is. We're trying to find the age where the area is at a maximum. To do that, we just find the derivative, which is this, f dash t. And we want to find it where the gradient is exactly 0. And we're told that we're finding a maximum basically, because you can get functions that look like this, where they can also be 0, but that's not going to happen in this case. Now, all we need to do is use some algebra to find out what t is going to be. So let's do that. I'm going to bring this over to this side here. So we have 2e Great, so when we're in the situation here, we're going to use a natural log. Natural log allows us to take the exponent and bring it down to the base level. I'll show you what I mean. So basically all I'm doing is this. Yeah, something like that. So plus actually, I want to explain this much better here. What happens is this is the same as saying ln e is ax plus b, and we know that ln e equals 1, sorry. So that means this actually equals ax plus b. And you'll see it in this scenario here. Now this is going to come down here. It's going to be multiplied by ln e, which is actually equal to 1. So I'm not going to put ln e because that's going to be 1. So t minus there plus 14 over 20 plus minus 1 over 40. Great, and now it's all just simple algebra and simplification. So let's get the t's on one side and everything else on the other side. Plus 1 over 40 ln 2 ln 0.5 minus 14 over 20 over 40 t equals whatever that is. I know this is going to equal ln, this is going to equal ln 4, 20. So we've got these big massive negative numbers. So I'm actually going to get rid of the negative numbers. So it's going to be ln 2 minus ln 0.5 plus. So that if you have ln, thanks to the nature of logs, one of the laws of logs, ln a over b. So in this situation here, it's going to be 2 over 0.5, which equals ln 3 over 40. T equals plus 21 over 20. And what we can do is from here is t equals ln plus 21 over And I guess I need a calculator to solve this one out. 4 plus 21 divided by 20 times 40 divided by 3. And so we get an answer, t equals 32.5. So there you go, mate. 32 and a half years old means you have the biggest size dating pool. So look forward to it. Love ya.